When school transitioned from traditional to online back in 2019, I was placed in a tough spot. The only gadget I had to my name was a phone, and there was no way I would be able to attend class, do assignments, take tests, and check emails, all at the same time on a small device, which by the way, only had 4 gigabytes of RAM. So I already knew that wasn't going to be an option for me. Like many other students at that time, I invested in a laptop. This bad boy served me well throughout my entire senior high school run. But greed wanted something more, something powerful, something efficient, something along the lines of a desktop PC, and I was willing to build one myself. Fast forward to graduation, I pressured my parents into helping me get all the parts I needed as a sort of graduation gift. And finally, it happened. I got all the parts. Now, some people will say the main attraction is the graphics card. After all, it is the most expensive part. But I would argue that it's actually the CPU, the brain of this whole operation. In my case, I got an AMD Ryzen CPU. Does anyone actually know what a CPU is made of? Well, that's exactly what I'm going to discuss in 3, 2, 1. I'm not going to discuss the manufacturing process of CPUs. Rather, we're going to talk about the material a CPU is made of. In essence, it has 4 main materials: silicon, copper, aluminum, and plastics. Silicon is a metalloid. It has both metal and non-metal properties. Fun fact: silicon is the second most abundant element in the Earth's crust. Silicon exists as a solid in room temperature. It has a metallic luster that makes it appear like most metals. It is very brittle, which is why you should never drop your CPU. Take care of that as if your entire net worth depends on it, because it just might. It is the most important semiconductor in the tech industry. In our specific use case, it is made to conduct electricity. It has a very high melting and boiling point, which are these numbers on the screen. Quick note, do not put a magnet near your CPU, as the silicon's electric conductivity reduces in the presence of a magnetic field. This could damage your CPU, and you definitely don't want that. The base structure of the processor is silicon. Copper is a non-ferrous metal, most commonly used in electrical wiring for its electrical conductivity and malleability. On top of that, it has great ductility. Just like silicon, copper has a high melting point and boiling point. The numbers are on the screen. Another reason why copper is used in wires in CPUs is because of its good machinability, which makes it easy to produce tiny and accurate electrical components out of copper. It is non-magnetic and corrosion resistant. Copper can be seen in the pins of a CPU for AMD, and for Intel they're on the slots the pins go into. Aluminum is a solid non-ferrous, non-lustrous, silvery white metal that is great for dispersing heat out of electronics, which is exactly what it is used for in a CPU. The casing for the CPU is made out of aluminum to remove the heat from the very hard-working parts that get hot. The melting and boiling points are on the screen. Aluminum doesn't rust, but it does corrode. Sometimes manufacturers coat the aluminum to be resistant to corrosion, but once that coat is damaged, it is once again vulnerable. Some silicon parts of the CPU can be replaced with plastics, though it's not as trendy, not yet. Plastics are still used in CPUs, but doesn't necessarily replace silicon's role. The most common type of plastic for this use case is polyethylene naphthalate, or PEN, which is a thermoplastic. It is a high-performance plastic which makes it viable for electronics like CPUs. It is clear, has high tensile strength, and doesn't shrink easily under heat. It doesn't absorb moisture, which is exactly what we want considering how sensitive a CPU is. The melting point is on the screen. It is also resistant to UV, which means it doesn't decay easily to UV radiation. And that's about it for the materials used in CPUs. Different manufacturers will have different grades and qualities for these materials, but their use is generally the same. There are some issues I have with AMD CPUs, however. The main issue being that the copper pins on the bottom of the chip can easily be bent. Beginners to building computers will definitely make the mistake of bending one of the 1,000+ pins, which makes the CPU unusable, by the way. A very common mishap for a very sensitive part, which could have been avoided if the pins were on the motherboard like on Intel chips. Another possible point of improvement would be the smoothness of the aluminum in the casing. The smoother the aluminum, the more contact the CPU has on a heatsink or cooler, which makes the CPU run at lower temperatures. Also, I am all for the idea of slowly replacing the silicon parts with plastic. Plastic is a lot cheaper than silicon, so using plastic will decrease the price of CPUs, which is good for consumers and good for the competitive market. So far, that's all I have to share regarding CPUs and its materials. Till next time, see ya!